In this video, you will learn how to install PatternJ and how to use it with a few short tutorials. PatternJ is a user-friendly toolset for ImageJ and Fiji. It will allow you to automatically analyze regular patterns. Such patterns are a very common type of organization in animals. You can find them in mussels, where sarcomeres repeat themselves along myofibrils, or in the way feathers are organized on the skin of birds, just to name a couple of examples. PatternJ will allow you to extract features of these patterns automatically. It can offer some basic analysis, and it provides an average pattern image. This video is the companion of a manuscript by Mélina Baeblin, Vincent Laureau, Franck Schneurer, and Pierre Manjol. If you want to publish data analyzed with PatternJ, please cite us. This will help us to make more tools that will help more people. You will find a reference of this manuscript on the PatternJ website. If you are not already watching this video on the PatternJ website, you will find the link of the website in the description of the video. You can also download a written version of this video as a manual on the PatternJ website. To use PatternJ, you will first need to install it. The installation is very simple. You first need to go to the PatternJ website to download the toolset. Follow the link provided and download the zip file. Once the zip file is downloaded, extract it and move its content to the ImageJ or Fiji macro toolset folder. You will find this folder by first going to the macros folder, where you'll find the toolset folder. There, copy the PatternJ file and the icon folder. If an icon folder already exists, just merge its content with the PatternJ icons. Do not modify the name of the folder, otherwise PatternJ is not going to work. For Windows and Linux users, the installation is finished. For Mac users, we just need to add one more step. In PatternJ, you will be prompted to open files and folder, but unfortunately on Mac, we cannot guide you on which folder to use because of the very minimalistic interface. To solve this problem, open ImageJ or Fiji. In the menu bar, go to Edit, then Options, select Input Output, and there check Use JFile Chooser to open save. This will not affect the way you work with ImageJ, but it will help us to guide you when you use PatternJ. Now that the installation is finished, open Fiji or ImageJ if you have not already done it. Click on the double red arrowheads on the right of the ImageJ interface and select PatternJ. You will see that a few new buttons appeared on the right of the ImageJ interface. These are different functions from PatternJ. You are all set to start analyzing an image. You can download the example I will now use on the PatternJ website or use an image of your own. Once your image is open, you will first need to do a manual selection on the patterns you will find interesting. Here I'm using an image of sarcomeres from Drosophila mussel that was provided by my colleague Vincent Laureau. Depending on your application, this selection can be a straight line or a curve. When I trace the selection, you can see that I go a little bit beyond the patterns at the edge of the selection. I do that to make sure that the patterns at the extremities of the selection will be analyzed. You can adjust the line width by double-clicking on the line icon. It is generally better to increase the line width to cover most of the pattern width. Once you're happy with your selection, click on the first button on the left of the PatternJ functions. This will provide an intensity profile plots for each of the channels of your image. There you can check the different features that define the pattern. In our example, in the first channel, each pattern consists of two bands. In a second channel, we have a more complex pattern consisting of a block and a band in its middle. This is typical of haloidine staining in mussels. In a third channel, each pattern consists of a single band. What will be the most interesting for most users would be to extract the position of these features, just like the position of the center of the bands or the position of the edge of the blocks. To be able to do so, you will tell PatternJ what to look for. To this end, you will click the parameter button. When I clicked on the parameter button, a window opened to ask for a folder. We want to make sure that the right parameters are used and that the results are saved in the right folder. Once the folder is selected, a pop-up window will appear. For each channel, you will set the features to be extracted. Depending on your application, you can select individual bands, very close individual bands if your bands are only a few pixels apart, blocks, block with a middle band, this is typical of sarcomeric actin, single pattern if the pattern is so complex that there is no simple mathematical function to describe it, or other if you do not want a given channel to be analyzed. You can also specify where the pattern is located. you can define whether you will draw your selection from edge to edge or center to center of a pattern. Different users may give different definition to what is an edge or a center, but the important thing is to keep consistent with your definition when you define where a given feature is located. In the example of the tutorial, I define as center of a pattern the locations where I start and finish the selection. Therefore, the features are localized on the edges of the pattern here. In our example, for the first channel, we said that we had 2 bands. Therefore, for channel 1, you will select individual bands in the drop-down menu. We have 2 of them per pattern, so we can just type 2 in a small box next to the drop-down menu. For channel 2, we have a block with a band in the middle, so I'm going to select this. And finally, in the third channel, we have individual bands, and we have a single band, so we're just going to leave the one which is in a small box. Now that PatternJ knows what to look for, we are ready to extract the features of the patterns. For this, simply click on the Extract button. When doing so, a new window appears with the intensity profile, on top of which the position of the features are precisely found, witnessed by vertical bars. It is important at this step to check that the features are extracted as expected. If yes, you can continue and simply save the results by pressing on the Save and Extract button. This is what I'm doing now. If unfortunately the algorithm did not fully extract the position of the features, try to modify the selection, making it smaller or larger. It is possible, if the noise is too large, that sparse positions are extracted. 2 solutions usually work. The easiest would be to use an optional features of PatternJ, which consists in applying a Gaussian blur to the image. The other option would be for you to use the convolution, either through a dedicated software, just like Wiggins, or using ImageJ, which also offers the convolution. Additionally, if the features of interest are dark, just like it would happen with electron microscopy images, you can invert the lookup table using the other optional button on the right of the PatternJ buttons. This function additionally corrects for background, which we found to be useful in many cases using electron microscopy images. Now that the results of the first selection have been saved, we can continue using another selection. Here you realize that you don't have to systematically set the parameters, as you only need to do it once. I make a new selection, check that PatternJ extracts well the position of the features, and then click again on Save and Extract to save the position of the features. In this tutorial, we'll keep only 2 selections, but we could have continued repeating these steps on more selections or more images. These images should all be in the same folder to make things simpler. Now we will reach the last step of PatternJ, the analysis. For this, simply press on the Analysis button. When you do that, you will first need to define one channel as a reference. It is used to estimate the length of repeats, and it is also used to align channels to obtain an average image of the pattern. Once the reference channel is selected, you will observe that 3 new windows appear. One is the histogram of the pattern length, and the 2 other ones contain the average pattern image and the average pattern intensity profile. The height of the average pattern image is related to the line width of your selection. If you draw multiple selections with different line widths, the smallest line width will be used to set the height of this average image. When the analysis is done, a new file appears in the analysis folder. These files contain all the position of the features as well as some fit parameters used to extract the position of edges. These files can easily be opened in Excel, R, or Python for further analysis. With the tutorial image, you can, for instance, estimate the distribution of distances between the 2 bands in channel 1 or the distribution of width of the blocks in channel 2. You probably realized that when we pressed the Extract and Save button, the ROI Manager window opened and a new ROI was added each time the button was pressed. It is the case because selections are saved at the Extract and Save step. It is possible to retrieve these selections with a dedicated function. For this, you first need the image to be opened. Once it is opened, go to the ROI menu and click on Only Open Selections Made with PatternJ. Follow the instructions and the ROI Manager will open with a list of your selections. You will then be able to navigate in the previous selections. You can potentially reanalyze individual selections. It is possible to extract features automatically from a list of selections. This can potentially be interesting if you obtain selections from a different tool. For the purpose of the demonstration, I will open a file containing selection previously saved with PatternJ. First, make sure that your image is opened. Then go to the ROI menu and choose Select ROIs and automatically extract. Follow the steps given by PatternJ and select a file containing your selections. After your selection is complete, PatternJ extracts the position in each of the selections one after the other and displays the results in a stack of intensity profile plots. The results of the extractions are also saved. At this point, you can analyze all the extracted positions, just like we did in the first tutorial, by pressing the Analysis button. If you were to do that just like I did in this tutorial, where results were already saved from the selections, you will duplicate the results. Therefore, use this tool only if the selections have not been used for extraction yet. Being able to analyze dynamic patterns is very important when you think of muscle contraction or developing somites. Because of that, we added the possibility to analyze time-lapse series. Let's start by opening a time-lapse series. You can find this example on the PatternJ website. After the example is opened, click on the Time-lapse button. Follow the instructions, set the type of pattern to be analyzed. Here we have 2 bands per pattern. Then a set of instructions appears. In a few words, the principle is to draw selections on a subset on images only. PatternJ will automatically extrapolate the selections in images in which you did not draw a selection. On this example with 100 images, you will need to draw only 5 selections. You can draw them in frames 1, 30, 50, 70, and 99. After each selection, press T on your keyboard to save this selection. The number of selections depends on the dynamics of your time-lapse. You will need to draw a selection each time there is a major change in your object, especially if the endpoints of your selection are moving. After a few selections are drawn, click on OK to let PatternJ analyze the selections. During the analysis, the image will disappear, and you will be able to follow the progress in the status bar. Because PatternJ is analyzing many images, in which it does many fits, the analysis takes typically a few tens of seconds. After the analysis is completed, the results are saved in the subfolder Time-lapse of the Analysis folder, and the results are displayed in 3 graphs. In the first graph, you will find the pattern versus frame or slice, as well as the average pattern size in a red curve. In a second graph, you will find the position of the patterns tracked over time. And finally, in the last window, you will find a stack of graphs with the position extracted for each of the time points. I hope PatternJ will be useful for you, and all the best for your analysis.